So in this lesson today, we're going to talk about angle relationships in triangles. We're going to be using AKSIOA 3D and 3E. By the end of today, we will be able to prove and apply triangle sum, exterior angles, and third angles theorems. First term here, auxiliary line, is an additional line drawn for the use in a proof. We're going to see that in the first thing we're going to do. A corollary is a theorem whose proof follows directly from another theorem. Interior set of points inside the line or shape. Exterior, same thing, outside. Interior angle is an angle formed by two sides of a polygon with common vertex. Exterior angle, an angle formed on the outside of a polygon. And then we have remote interior angles is an interior angle of a polygon that's not adjacent to the exterior angle. Going to use all these terms today. So first thing we're going to do here is the proof of a triangle sum theorem. It says given triangle A, B, C over here on the right, prove that if we add 1 to 2 to 3, these angles, they equal 180. It says construct an auxiliary line parallel to AC through B. So AC is right here. This BD is a parallel line. So we're going to go ahead and mark it as parallel. This is parallel with this side right here, right? And through point B, okay? Then it says AC is parallel to BD. That's given because we drew an auxiliary line right here that is parallel. Then it says angles of a straight angle. So what are we going to do here? So we are going to see the straight line right here. We have three angles that form that straight angle. So we're going to say the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5, that's going to be equal to 180. Then our proof says the measure of angle 1 is equal to the measure of angle 4. So let's go ahead and mark that in our drawing. The measure of angle 1 is equal to the measure of angle 4. Why would that be? That would be because they're alternate interior angles, right? So we're going to write alternate interior angles theorem. And I'm just going to abbreviate theorem, okay? Then it says we have another pair of alternate interior angles. So that would have to be angle 5 over here is congruent to angle 3 or equal, right? So the measure of angle 5 is equal to the measure of angle 3. Okay. So now we have all this information above here, and then we have that the measure of angle 1 plus measure of angle 2 plus measure of 3 is equal to 180. So look up here, we had the measure of angle 4, right? Plus 2 plus 5. Okay, so we got our 2 down here, and notice we said that the measure of angle 5 is equal to the measure of angle 3, right? So right there's angle 3. We have the measure of angle 1 down here is equal to the measure of angle 4, and we had angle 4 up there. So this was substitution. This is just the substitution property. That's all they did there, okay? And we have now proven that when we add these three angles, these interior angles together, they equal 180. All right, so that was the triangle sum theorem. And again, what it says is that when we add the three angles together inside the triangle, they always equal 180. So example 1 up here, what we're going to do is we're going to add angle A plus angle M plus angle T, and they should equal 180, right? Okay, so we're going to do our 27 plus our 82 plus the measure. I'm going to go ahead and put the measure in front of there, right, of angle T, and say that's equal to 180. So I want to add the 27 to the 82. I get 109 plus the measure of angle T equals 180. And then what would we have to do to solve it is subtract that 109 from both sides, right? Subtract 109, subtract 109. So the measure of angle T is going to be equal to 72 degrees. And the way you can check that is, again, is plug it back up there and add all three together, make sure it equals 180. All right, this is our we do. So once again, we're going to add these two angles together. So we're going to add 40 plus 80. And x, right, and that equals our 180. So ultimately we're just going to do, this is 120 plus x equals 180, right? Most of you are just going to add those together and subtract them. So That's going to be x is equal to 180 minus our 120. So x is going to be equal to 60 degrees. Okay? All right, this next one, you guys go ahead and do it. And again, this time I would just add them together and subtract them from 180 now that you've seen the process a couple times. So let's do this. 40 plus 70 equals 110, right? And then do 180 minus 110, and that equals 70 degrees. So this is actually an isosceles triangle, isn't it? Because it has two base angles that are congruent. All right, this next one says, same process, but now we have some equations, okay? So it says find x, m, r, and actually we're going to find all the angles, okay? So again, we're going to add the angle r plus the angle s plus the angle t, and we're going to set them equal to 180. Okay, so I'm going to go 3x plus 9 plus 8x minus 1 plus 3x plus 4 equals 180. Now we're looking for our like terms here, right? So we've got a 3x there, an 8x there, a 3x there. So when we add all those together, that's going to give us 14x, right? So we get 14x, and then we're also going to add our our constants. So 9 minus 1 is 8, and 8 plus 4 is 12. So this is going to be plus 12. And that's going to be equal to our 180, right? So now what do we have to do? We have to subtract the 12 from both sides, don't we? So subtract 12 from both sides. So that's going to give us 14x equals, what is that? 168. And then we're going to divide that by our 14, because 14x means 14 is being multiplied by x. So x is equal to 12 here. Now, to finish this problem, we need to go ahead and plug that back in for these angles, right? So our x is 12. So now we're going to plug it back in for angle r. So at the measure of angle r is going to be equal to 3 times 12 plus 9, and that's going to be equal to 45 degrees. Okay. Then I'm going to do the measure of angle s, and that's going to be 8 times 12 minus 1. So I want to do that one. I got 95 degrees. Okay. And then we've got the measure of angle t, and that's going to be 3 times 12 plus 4. So this one is going to be 40 degrees, right? Okay. Again, the way you check this is add 45 to 95 to 40. Do they equal 180? Again, right here I'm saying add these three together to check it, and do they equal 180? They do. Okay, that's the way you check it. All right, on this we do, I would like you guys to try this and then come back to me when you're done. So here we go again. We're going to add these three together. 7x minus 1 plus 7x plus 8 plus 5x plus 2. And all of those equal 180. Remember, again, we're looking for our like terms, our 7x, our 7x, our 5x. That would be 14 plus 5. That's 19x, right? And then we've got our minus 1, our 8, and our 2. That would be 10 minus 1, which is 9. And that's equal to our 180, right? So we are going to subtract the 9 from both sides. So this is now going to be 19x equals 171. Divide both sides by the 19. So x equals 9. Okay? So now we are going to plug in the 9 to find all the different equations. So we've got the measure of angle A. So that's going to be 7 times 9. 7 times 9, that's 63 minus 1, so that would be 62 degrees. Then we've got the measure of angle B. That's also 7 times 9, but plus 8. So this one is 71 degrees. And then we've got the measure of angle C. So this one's going to be 5 times 9. That's 45 plus 2. That's 47, right? Now once again, remember the way you check. Add all three together, make sure they equal 180, and they do. Okay? All right, you guys go ahead and do this. You do too, and come back to me when you're done. So here again, we're going to do our two. Actually, let's start with the x. We'll start with x minus 10 plus 2x plus 5 plus 35. That equals our 180. Okay? So again, we're looking for our like terms here. So we have an x and an x. So that's going to be 3x. Then we have a negative 10, a 5, and a 35. 5 plus 35 is 40. 40 minus 10 is 30, right? So this is plus 30 equals our 180. So we're going to subtract the 30 from both sides. So that's going to give us 3x equals 150. How many times does 3 go into 150? 50 times, right? X equals 50. So we have that x equals 50. So now we have to plug that back in to find those two angles, right? So we're looking for the measure of angle M, and that's going to be 50 minus 10. So that's going to be 40. Then we have the measure of angle N, and this is going to be 2 times 50. That would be 100. Plus 5, that's going to be 105. Now remember, our third angle was already given to us. So I'm just going to scroll down here a little bit and we're going to add it. And then we got our 35, right? So when we add these three together, 105 plus 35, that's 140, and 140 plus 40 is indeed 180. Remember, this is how we check it, and you should. Okay, so this next one is a corollary. So this is the acute angles of a right triangle are complementary. Complementary, remember, means they add up to be 90. And why is that? Because 180 minus 90 is 90. So if I add these two angles together, they equal 90, because 90 plus 90 is 180, okay? Then also we have the measure of each angle in an equilateral triangle, 60. That's because 180 divided by 3. Again, we're talking about right here, 180 divided by 3 equals 60, right? Okay, that's why. All right, so up here it says example 3, find x, the measure of E and the measure of F. Okay, this time again, remember, if 90 is used here, then these two angles are going to add up to be 90. So we can say 2x plus 1 plus 5x plus 5 equals 90 degrees, okay? So once again, we're looking for our like terms, 2x and 5x. That's going to give us 7x. Then we have our 1 and our 5. That's going to be 6. And that equals our 90, right? So we are now going to subtract 6 from both sides. 7x equals 84. And hopefully you guys know that when you divide 7 into both of these, x equals 12. Now to find those angles, we're just going to plug that 12 back in, right? So we're going to say the measure of angle E is equal to 2. Well, it'd be great if I could write 2 times 12 plus 1, that's 24, plus 1, that's 25. Okay. And then the measure of angle F is equal to 5 times 12. That's 60 plus 5, so that's going to be 65. And once again, if I add these two together, they should equal 90, right? 65 and 25, guess what? That equals 90. And remember, 90 plus 90 equals 180, and that's still the triangle sum theorem, okay? All right, we do, again, this here is pretty easy, right? So if we're trying to find the measure of angle 1, if these two, if angle 1 plus 90 or plus 77 equals 90, can't we just do 90 minus 77? And that equals 23 degrees, right? Let me double check, yeah. So the measure of angle 1 equals 23 degrees. All right, you do 3A. Go ahead and do this one. Come back to me when you're done. So most of you probably just did 90 minus 41, right? And 90 minus 41 is 49 degrees. Right? So that's equal to the measure of angle D. I don't know why I put O. There. Okay. Now, this one is a word problem. See if you guys can do it. The measure of one of the acute angles in a right triangle is 63.7. What is the measure of the other acute angle? Pause the video, see if you can do it. Come back to me when you're done. Okay, so this one's, all you have to do is 90 minus that 63.7, right? So when you do 90 minus 63.7, don't you get 26.3 degrees? Okay? All right, so this is our next one. This is the isosceles triangle theorem. It says, in any isosceles triangle, the angles opposite the congruent sides are also congruent. So what does that mean? Notice we have 2 tick marks here. 2 tick marks here. That means this angle and this angle have to be congruent as well. Okay. So over here, when we start talking about this one, because it shows that this angle is congruent with this one, we can say that this side is congruent with that side, right? It's an isosceles triangle. Okay. So what does that mean? We're going to set these equal to each other, right? So 4x plus 12 is going to be equal to 5x minus 3 because it's an isosceles triangle. The base angles are congruent. So we're going to subtract 4x from both sides. So now my x's are gone, and this is just x. Then we're going to add 3 to both sides. So that's gone, and we have 15. So x is equal to 15. So now to find the base angles, which is what it says we should do, we got to put it back in. So and this is a great way to check the problem too. 4 times 15 is 60 plus 12. That would be 72 degrees, right? So let's check the other one as well. 5 times 15 is 75 minus 3 is also 72 degrees. These should be equal, and if they're not, you know something's wrong. Okay. This we do is a little bit different, right? Because we have the base angles are congruent. It shows us that in the diagram, right? Shows us that this angle is congruent with this angle, right? But we now have the top angle, right? Okay, so we're going to do 180 minus that 58 to figure out what that is, and then we're going to divide that by 2, okay? So when we do that, that's going to give me 122, and then we're going to take the 122 and we're going to divide it by 2 because both those base angles are the same. So that means it's 61 degrees. That is the measure of angle 1 is 61 degrees. Okay. So the last problem, go ahead and do it and come back to me when you're done. All right, this one's a little different too, right? Okay, so the first thing we know is that this is also 40, right? So if those two angles are 40, 40 plus 40 equals 80, right? And so to find that top angle, we're going to do 180 minus 80, and that's going to be 100. So this angle up here is going to be 100 degrees, right? So the measure of angle A is 100 degrees, and the measure of angle B was equal to 40 degrees. All right, here's our next one, third angles theorem. So the third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third pairs of angles are congruent. That makes sense, right? So let's just throw some numbers in here. So if I told y'all this angle here was 30, that means this one's 30, right? And if I told you this one was, let's just say 60. Now let's go bigger. 80. We'll say 80. That means this one over here is 80, right? And then that means that that's 110, because 80 plus 30 is 110. So that means this other angle over here would have to be 70, right? And that would have to be 70. Okay, so again, if two angles in a triangle are congruent, then the third angles have to be congruent. So up here, for example 5, it says find y, the measure of angle k, and the measure of angle j. Okay, so what are we going to do with these two angles? We see that f is congruent to, so we can say the measure of angle f equals the measure of angle I. The measure of angle g equals the measure of angle h, right? So then we know that K and J are congruent. So I'm going to put 3 arcs up here, and I'm going to put 3 arcs right here. Okay? So I'm going to be able to set the measure of angle K equal to the measure of angle J. So that's going to give me 4y squared equals 6y squared minus 40. Okay? So we have some like terms here. The 4y squared and the 6y squared are like terms. So I'm going to move some stuff around here. So I'm going to subtract the 6y squared. I don't usually do that, but I'm going to do it just because I don't want to have to move things twice. Okay? So when I do that, that gives me negative 2y squared equals negative 40, because this is now gone, right? Okay. So now we're going to divide by that negative 2, and this is why I don't like doing this, but I'm doing it anyway, so just so you guys can see it. So when I divide by a negative 2 and a negative 2, the negative 2's are gone, and I got y squared equals a negative divided by a negative is a positive, right? So that's going to give me a positive 20. So now what we're going to do, if I can get my mouse to work, and it's not wanting to for some reason, so okay, so now we have y squared, but we need a y, right? Or oh, do we? So we just need y squared, because y squared's in both problems, right? So look up here, y squared, y squared. We could solve for y, but what is that going to prove for us? Nothing. Okay, so 4 times, so up here, for the measure of angle K, it's just 4 times our 20, isn't it? Because y squared is equal to 20. So the measure of angle K is equal to 80, which means that should be the measure of angle J as well, right? Okay, so the measure of angle J is going to be equal to 6 times 20. That'd be 120 minus 40, which is also 80 degrees. Okay? All right. Go ahead and do this we do over here, and then come back to me when you're done. So here again, we know that P is going to be congruent to R because we've got one arc at M and R. We've got 2 arcs at N and S, so that means our third angles have to be congruent, right? So here again, we got 2x squared is going to be equal to 4x squared minus 32. So once again, I'm going to go ahead and subtract the 4x squared. So now that's gone from there. And I got a minus 2x squared equals minus 32. This time I'm going to divide both sides by negative 2. And so x squared is equal to 16. Now once again, x squared is in both these problems, so we don't have to go any further than that. We could if we wanted to, because we know that x squared, the square root of x squared, if we take the square root of this right here, don't we know that x is equal to 4, right? Okay. But we don't really have to do that here. Why? Because x squared is in both problems. So when we look at the measure of angle P, it's equal to 2 times 16, which is 32 degrees, okay? And then when we look at the measure of angle T, it's equal to 4 times 16, which is 64, minus 32 is, guess what again? 32 degrees, okay? So let's see if you guys can do this one. Come back to me when you're done. Okay, once again, notice that the measure of angle R is going to be congruent to the measure of angle T, right? Okay, so can we find the measure of angle M? Did I say R? I meant to say M. The measure of angle M, what is its measure? Couldn't we add these two together? So 55 plus 65, that's going to be equal to 120, right? And then to find the measure of angle M, wouldn't we do 180 minus 120? That's going to be 60 degrees, right? So the measure of this angle is 60. So then it says, what's the measure of angle R? So the measure of angle RM was 60. Okay, so that's 60 right there. The measure of angle R is 2 arcs. Y'all see these 2 arcs right here? So we have 2 arcs down here. So that's going to be 55 degrees. Then we have S, and S has got 1 arc, and this has got 1 arc, so this is going to be 65 degrees. Then it says, what's the measure of angle T? Well, the measure of angle T would be 60, because that was the measure of angle M. and then it asks what x is. So we're going to say 60 is equal to 2x plus 30. We're going to subtract 30 from both sides. So that's going to be 30, right? 30 equals, this is now gone, 2x, divide both sides by 2, and x is equal to 15. There we go. So our next property we're going to talk about today is the exterior angles theorem. So the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So we need to know what that term means, remote interior angles. These are the angles that are not next to the exterior. So angle 4 right here is the exterior angle. So our remote interior angles would be 1 and 2 because they're not next to it. So when we add those two angles together, they equal the exterior angle. And there's a good reason for that. This right here is a line. And what's the measure of a line? 180, right? So if we subtract angle 3 from 180, don't we get angle 4? And what is the sum of all the angles inside the triangle? They are 180 degrees, right? So again, this says angle 4 is our exterior angle, and angle 1 and 2, angle 1 and angle 2 are our remote interior angles, okay? So we're going to go ahead and do this problem right here. We'll move it up a little bit. So this says find XM, find the measure of angle B, and then find BCD and BCA, okay? So we have angle A here, right? So when we add these two angles together, so when we say angle A plus angle B, that's going to be equal to our exterior angle, which is BCD, right? Angle BCD, that's our exterior angle. So what we're going to do to solve this is we've got our 15 plus our 2x plus 3, and that's going to be equal to our 5x minus 60, okay? So we're going to combine our like terms right here first. So I'm going to have 2x plus 18 equals 5x minus 60. Now we're going to subtract that 2x from both sides, move it to the right. Okay, so that's gone from here now, so we have 3x here. And then we're going to add 60 to both sides. So we're adding 60 over here, so that's 78 is equal to 3x, so that's gone from there. Let me extend this page so I have a little more room to work. So then we're going to divide both sides by our 3, right? Divide by 3 here, divide by 3 here. So x equals 26. Now, to find all these other angles, we have to plug that back in. So to find B, so the measure of angle B is equal to 2 times 26, which is 52, plus 3, and that's 55, right? Okay. Then it's asking us to find BCD. BCD is our exterior angle, right? So the measure of angle BCD is equal to, look, BCD right there, there's our angle. That's 5 times 26 minus 60. Do that in your calculator, and you get 70 degrees. Okay? Then we have angle BCA. The measure of angle BCA is equal to, okay, y'all see BCA is that angle right there. Well, we just found the exterior angle, right? So notice, again, that these two angles, this angle here and this angle here, form a line, right? See that line right there? So we can do 180 minus the 70 that we just found, and that's going to give us that angle is 110 degrees. Okay? All right, let's see if you guys can do this next one. Come back to me when you're done. Maybe not. Okay. So this is right here. So this angle is 90, right? So aren't we going to do, again, remember, we're going to add these two together. So we're going to do 2z plus 1 plus 90. That's going to be equal to our exterior angle, which is 6z minus 9. Again, we're going to combine some like terms, 90 plus 1. So 2z plus 91 equals 6z minus 9. So we're going to subtract 2z from both sides. That's going to give us 4z. Then we're going to add 9 to both sides. So that's now gone from there, and that's going to be equal to 100. How many times does 4 go into 100? 4 quarters make $1, right? So z equals 25. So now we're going to find the measure of ACD. ACD is our exterior angle. ACD right there. So the measure of angle ACD is equal to 6 times 25. That'd be 150 plus 1. So that's going to be, no, not plus 1, minus 9. Wow. Where'd I get the plus 1 from, y'all? I was looking at the wrong one. Minus 9. So that's 150 minus 9, which is 141. So this is 141 degrees. Okay, now let's see what where the other angle is. Then it's asking us for angle A up here. So this is angle A. So the measure of angle A equals 2 times 25. That's 50 plus 1. So that's 51 degrees, right? Okay. Then it asks us for angle BCA. So BCA is that angle right there, okay? So the measure of angle BCA, can't we just subtract that exterior angle, which was 141 from 180? So we're going to do 180 minus 141. And when I did that, I got 39 degrees. All right, so here's your U try. Go ahead and do this one. Come back to me when you're done. Okay, once again, we're going to add angle C plus angle D, and that's going to be equal to the measure of angle, I'm just kind of shortening it without the measure, ABD, right? So we're going to add this angle to this angle, and they're going to be equal to that angle out there, okay? So that means we're going to do 7x plus 5 plus 60, and that's going to be equal to our 20x. So combine some like terms, 7x plus 65 equals 20x. Subtract the 7x from both sides. So this is now gone. So we got 65 equals 13x. Divide both sides by 13, right? So x is equal to 5. So we're going to plug that back in. 7 times 5 is 35 plus 5. That's 40 degrees for the measure of angle C, right? And then out here, we're going to do 20 times 5, and that's going to be equal to 100 degrees, right? So we have one other angle to find, this one right here, right? That would be CBD. And to find CBD, we're going to do 180 minus the 100, because this is on the outside. See that straight line right there? So that's going to be equal to 80 degrees.